Okay, I am going to get started. I am so excited and thankful for Dr. Blair Wylie's time today. I'm joined, of course, by my co-founder, Dr. Ali Melnick, Urogyne at Cleveland Clinic. And I'm a assistant professor of OBGYN at the University of Rochester, and we co-founded OBGYNs for Sustainable Future, and we're so excited to have Blair here today. She is a professor of obstetrics and gynecology at Columbia University. She is a clinician, she's a practicing MFM, and she's been researching and publishing and speaking on the topic of the intersection of climate change, women's health, maternal health, and especially our topic today, infectious borne diseases. She's been working in this area for over 10 years and actually recently helped to found and is now director at the Collaborative for Women's Environmental Health at Columbia University. So really excited to have you here today, Dr. Wylie, and excited to learn not only about the topic that you'll be speaking about, but how clinicians can apply this knowledge and how they might be able to follow in your footsteps and potentially start some other places, some centers around the US where we're talking about and investing in the intersection of climate and women's health. So without any further ado, I'm going to turn it over to you, Dr. Wylie.
Thank you. Thank you so much for both of you for inviting me to give this talk today. But more importantly, thank you for founding the OBGYNs for Sustainable Future. And I hope that our ranks grow exponentially over the next few months to years. So by way of introduction, I am a practicing obstetrician, maternal fetal medicine physician, and got interested in this topic initially through research. My research originally began, let's see if I can get, are you seeing my slides forward? Do you guys see that?
Oh, yeah. Yeah,
okay.
we do.
Just making sure that that was moving forward.
Oh, yeah. Yeah, of course.
So I originally got my start in the area of malaria, and then as normally, careers evolve, wandered into household air pollution in Western Africa, that then led its way back to pesticides and the recognition that all of these things were really interwoven by the looming threat or the current threat of climate change on health. I have no relevant financial disclosures. I have been supported by research and do serve as the obstetric consultant to something called the Pediatric Environmental Health Specialty Unit Network, which is funded by the AAP, and they claim no sort of endorsement of what I am to say today. There's the acknowledgement there. So what I'm hoping to talk about today is something that maybe we don't get as much of a chance to speak about when we're talking about climate change and health. And that's how the climate change crisis has impacted the emergence or even reemergence of some infections and increased the reach of others that can negatively impact pregnancy and reproductive health, specifically those that are borne by vectors. I want to touch upon the fact that the distribution of these infections is not equal, and there's a lot of inequity and injustice in who bears the brunt of vector-borne illness in relation to climate change. And then end by speaking on how challenging what to do about this is. Some of our strategies to control vectors may have some downsides, and how do we begin to sort of weigh the risks and benefits of controlling vector-borne diseases. So most of you have probably seen this slide or some version of this, which is really trying to capture how climate change impacts health. And we're going to focus on this sort of upper right-hand corner, how climate change affects vector ecology and therefore may be intensifying vector-borne disease in our world. As by way of review, a vector is an organism, typically an arthropod, that transmits some sort of pathogen. It can be a virus, a parasite, a bacteria, and it transmits it from a host to a human being, and then that cycle continues. On the right is a smattering of a number of vector-borne diseases that impact human health, and this is just a fraction of what there is out there. When we think about the burden of disease from vector-borne illnesses, it's thought that there's 1 billion infections a year from them, causing over 1 million deaths and contributing to about 1/6 of all disability or dailies worldwide each year. And the incidence of these diseases and their impact on the global burden of disease is increasing. Here in the US, it's thought that over the last 10 years, vector-borne illness has more than tripled. When you look at the role that climate change plays in increasing vector-borne illness, over 100 different vector-borne illnesses seem to be exacerbated or intensified by our warming climate. So how might that be? What's going on? So a warming climate can certainly change the geographic range and spread of the vectors or even the animal reservoirs. It can prolong the transmission cycle or seasons, the longevity for which the vector survives in a given year. And with climate migrations, we're seeing disease vectors move from one geography to another that they may not have been before. When we think just about temperature, we know that it's not so simple and straightforward, and there's a number of different impacts. So hotter temperatures can improve the survival of some vector species and pathogens. There are optimal temperatures for each, and there may be a temperature beyond which survival starts to decrease for some of the vectors. Temperature can also change the susceptibility of the vector to the pathogen. It can change how fast they develop and grow. It can change their feeding habits. It can change the likelihood of their contact with the host if populations are spending times in closer proximity to the vectors. Here is just a slide showing the thermal biology of different mosquitoes in the different colors. Each of these carry different diseases. You can see down at the bottom, Zika virus, dengue virus carried by the Aedes mosquitoes. Each of those mosquitoes has an optimal temperature. So as our climate warms, it's going to impact these vector-borne illnesses in different ways, and sometimes complicated and difficult to predict. Here's another slide that it's not just the R0 or the survival of the disease, but it affects specific attributes of the mosquitoes: their biting rate, their fecundity, how fast they develop, their lifespan, their survival. And so when we begin to try to model how climate change impacts vector-borne diseases, it becomes quite complicated. We know that with a warming climate, there's more precipitation. The heat increases evaporation. We're seeing more rain. We're seeing more extreme weather events with extreme precipitation. That can change vector habitat. So it may increase the habitats for the larvae, although notably, if there's extreme flooding, that could actually eliminate some habitats. Drought and water stagnation may increase habitats from pooling. When there's less flow of rivers, you may have more places where vectors can reproduce and survive. Drought can also impact human behavior. So putting out cisterns can be a nice breeding ground for mosquitoes and other vectors. Humidity, not just temperature, can affect the vector survival and activity, both increasing and decreasing it. And as I mentioned, with climate disasters, we're going to be seeing more migration and displaced populations, bringing with them vectors as well. So I think kind of by way of background, we know that the warming climate is increasing the intensity and spread of vector-borne diseases, but it's difficult to predict precisely what's happening. As OBGYNs, I think there are a couple of key vector-borne diseases that we need to be aware of that may be in our clinical repertoire more frequently moving forward. And I'll start with malaria, in part because that's kind of where my own research career began. Malaria has been with us for millennia, and it still impacts a number of people each year. There's thought to be 200 to 300 million cases per year. About almost half of the world is at risk, 500,000 deaths per year. And in the last couple of decades, there's been tremendous efforts to roll back malaria, to intensify efforts to control the vector, to treat the disease. And we've had a lot of success, but this has started to turn a corner, and we've seen recent increases in the last several years in malaria. As obstetricians, malaria is pregnant people pose unique risks to malaria infection. And so for that reason, it's important for us to understand how it impacts pregnancy. Estimated that 50 million pregnancies are exposed, leading to 10,000 maternal deaths, 200,000 low birth weight infant deaths, and 200,000 cases of severe anemia. And these estimates are likely a bit old, but it's an important disease for us. Just like any parasitic disease, there's a complicated life cycle. So the disease is carried by Anopheles mosquitoes. The infected Anopheles mosquitoes will inject the parasite into the human bloodstream, where it's sort of taken up shop in the liver, where it then matures, is re-released into the bloodstream, and infects red blood cells. Why is it so different and interesting in pregnancy? For one, pregnant women are more likely to be bitten by mosquitoes than non-pregnant folks. They breathe faster, emit carbon dioxide, which is a chemoattractant for mosquitoes. And in this study, which is sort of a controlled biting study, if you will, the researchers counted the number of Anopheles mosquitoes that entered the bed nets per night, and they could see that if there was a pregnant person sleeping under that bed net, more mosquitoes would enter. Again, it's thought because of the higher respiratory rates, the carbon dioxide, the higher carbon dioxide led to more mosquitoes entering. It's also known that pregnant individuals are more susceptible to malaria than non-pregnant adults. We see the odds of parasitemia increasing during pregnancy and returning to postpartum levels after delivery. Pregnant folks are more likely to have severe malaria than non-pregnant adults, increased risk of hypoglycemia, pulmonary edema, severe anemia, and death. So these are individuals who've been living in malarious areas, have developed a partial immunity, and then for some reason, which I'll explain in a minute, pregnancy unmasks vulnerability again, like they were in their childhood. So perhaps the most fascinating bit of the epidemiology, and the reason to explain those other attributes that I described, is that malaria is found more common, or it's more frequent and more severe among first-time pregnancies compared to multiparous individuals. And this is pretty unique to this infection. And what we know now is that malarial parasites sequester in the intervillous space of the placenta. What happens is, I'll skip forward, they attach to something called chondroitin sulfate A on the syncytia trophoblast layer of the placenta. And chondroitin sulfate A is it's in our joints, and so not typically in the vasculature. So a parasitized red blood cell, essentially think of it as a sort of knobby-like thing that likes to stick to the sidewalls of the vasculature. So when you're bitten with an infected mosquito, you get a number of different strains of the parasite into your bloodstream. And if you're living in a malarious area and you're growing up in a malarious area, those parasitized red blood cells start sticking to your vasculature, including in your brain and other organs, and you develop immunity to the strains that stick to the vasculature throughout your body. Then all of a sudden, for the first time that you're pregnant, you have a placenta, and this CSA, or the chondroitin sulfate A, is exposed to the bloodstream. So all of a sudden, those parasitized knobs that can attach to that stick. And so you get these dense parasitemias in the placenta that that otherwise would not have been or would have been cleared by the body. I hope that makes sense, and people can ask me later on in the question sessions if I didn't do a good job of explaining that. So here's just some examples. So you see higher rates of placental malaria, higher parasite densities, depending on the parity. So what about climate change? This is the focus of our talk here. We know that the Anopheles mosquito that transmits malaria has an optimal temperature range, as does the parasite itself. And so that optimal temperature range lines up around 28 to 32 degrees. What we know is that malaria happens in sort of different patterns depending on the humidity and the temperature. There's areas where there are seasonal, sort of endemic outbreaks of malaria, and then other places where it's very episodic. We know that El Nino may increase local outbreaks. And here's some projections, again, difficult to precisely predict. But in Africa, where we see a huge burden of malaria, you'll see in some places that there are going to be new areas where it's transmitted throughout the year and endemic in purple. This is projected in 2030, and other places where you see new seasonal outbreaks. So places that were at higher latitude, higher altitude before, you may see malaria where it wasn't before. You may see it being transmitted around the year in places where it used to be fairly episodic. And this you can see marching out forward. There's also thought that there's going to be a shift and an increase to northern latitudes, with projections that malaria may be here and transmitted locally in the US by 2050. And many of you may have seen the reports this summer of a few cases of locally acquired malaria. So not a case that someone brought from travel back home, but from an uninfected individual who had no travel history. So again, I think that as OBGYNs interested in caring for our patients is interested in the climate, I think malaria is going to be more important to us in the US as it has been very important to our colleagues around the world. Another example of a disease, a vector-borne illness that is going to be affected or is already being affected by climate change is Chagas disease, or American trypanosomiasis. Chagas disease is endemic in Central and South America. It's thought to be spread by the feces of the triatomine bug. It is also a parasitic disease. The parasite is I can't even say it. T. cruzi is a better way of saying it. And it's really originally thought to be a quite rural disease where these bugs sort of congregate in the holes in the walls of thatched houses and villages, and then deposit their feces, which then either get into contamination of foods, or people touch the bug feces and wipe their eyes, or have a break in the skin, leading to disease. There's the parasite on a blood smear, you can see. So currently, the disease is endemic in 21 countries, affecting 6 million people. 70 million people are at risk for becoming infected. It's thought that there are 30,000 new cases annually, causing 12,000 deaths each year. And the reason why it's of interest to obstetrician gynecologist is the mode of transmission, that it can cross the placenta, and there can be congenital Chagas, either before delivery across the placenta, during the delivery, or even during breastfeeding. So the types of Chagas, there's acute Chagas, which is typically asymptomatic, lasts for about 48 weeks. When people are symptomatic, they may have malaise, fever. This is the Romana sign, where you have kind of an infected, sort of a swollen eyelid where the parasite was introduced. There may be some minor EKG changes that are noticed in acute Chagas if it is caught. Very, very rare to have severe sequelae in this acute phase, rare cardiac complications of the acute phase. What we worry about is the chronic form of Chagas. So if left untreated in the acute phase, and again, sometimes it's hard to catch, although if caught is treatable by antiparasitics, what happens in the long term is sort of two manifestations, a digestive form and a cardiac form. And the digestive form is secondary to destruction of the autonomic ganglia in the GI tract, leading to complications like megaesophagus, megacolon, which you might imagine have clinical sequelae. That's a little bit less rare than the cardiac form, which is more responsible for the mortality associated with chronic Chagas. You can lead to abnormalities in the conduction system, heart failure, and death. So when we're trying to prevent these chronic complications from this disease, trying to identify it during pregnancy is important. Vertical transmission can occur more frequently in acute Chagas, but even amongst those with chronic Chagas, about 5% will pass the parasite on to the infant. And while the risk factors for vertical transmission aren't completely defined, it's thought that both the level of parasitemia, as in acute Chagas, HIV, and maybe the lineage of the parasite affect the chance of vertical transmission. Most of congenital Chagas is asymptomatic, so might go undetected by a pediatrician. And if symptomatic, those are some of the common things that are found. Rarely congenital Chagas causes troubles in the newborn period, but really it's the risk for chronic manifestations in life. We haven't paid a lot of attention as a field to what potentially the pregnancy complications of Chagas are, but there are some increased risk of abortion, stillbirth, prematurity, and impaired growth with Chagas disease in pregnancy. We know there's been a lot of attention in the Central and South American countries to screening for Chagas disease, to treating for it. And there's been great success in reducing incidence from the early 1980s, when about, roughly 4% of the population was at risk, down to, under 2% by about 2005. There hasn't been much progress since then, and maybe even a slight increase in the last years or so. We think that climate change may be playing a role in shifting the habitat of the bug that transmits Chagas to higher latitudes. So these bugs are in existence, or they're in the southern United States. They're able to transmit the parasite at higher and higher latitudes compared to when before. And what was originally sort of a rural disease is beginning to become more of an urban and peri-urban disease. And that may change the likelihood of us coming, sort of having to deal with this within our own borders here in the US and certainly in the world. Switching gears once again to something that's probably even a little bit more familiar to this audience, Zika virus. Just by way of review, Zika virus is a flavivirus. It is related to dengue, yellow fever, a number of other diseases that are borne by vectors. And its risk is really its neurotropism and its ability to affect the developing brain in particular. It's spread again by mosquitoes, from humans to the mosquito back to the humans. And in our situation, the transmission across the placenta is the one that we fear. The vectors that transmit Zika are the Aedes mosquitoes. The most efficient vector is Aedes aegypti, feeding primarily on humans. Unlike the Anopheles mosquito that transmits malaria and bites mostly at night, these mosquitoes are daytime feeders, and they're very interested in biting humans, if you will. So the Anopheles mosquitoes would much prefer to bite animals. The Aedes mosquitoes are really, they get their blood meals from humans most. The range of these mosquitoes is quite large, and I'll show you sort of some modeling for that in the future. But if we think back to the Zika virus outbreaks, and really we sort of all lived through this as practicing clinicians, while we knew that Zika virus could cause human disease, it really didn't come to the fore until the last 6 or 7 years, when you start to see these outbreaks in Polynesia, the Pacific Islands, and then Brazil and Colombia. What was so prominent in this was the microcephaly that was detected. So those of us, I'm a practicing MFM, we do a lot of ultrasounds, we see some small heads, but we don't see profoundly small heads. And they, in this history of the Zika outbreak, you can see just this marked jump in the cases of microcephaly, and it was attributed to the Zika virus. And it's not just microcephaly, but other impact on the developing brain that congenital Zika virus syndrome can affect. So here's predictions on climate change and the vector that causes Zika virus. So this mosquito is one of the ones that can survive in some of the hottest temperatures compared to even the mosquitoes that transmit malaria. And so here are the current areas where this vector is, and as you can see, moving forward, it marches to higher and higher latitudes. And this is a projected change in the population at risk of these mosquito vectors in the billions. And it's just marching up as time goes on. These mosquitoes are also the vectors for dengue virus. And dengue virus also has implications for pregnancy. Many dengue infections go unnoticed. But they can result in severe infections, thrombocytopenia, hemorrhagic shock. Pregnancy makes you at higher risk for those things. It can affect the fetus and the placenta, and we're just beginning to learn more about dengue and pregnancy, in part because many of these infections have gone unnoticed or unrecognized as specific to dengue. So what about inequity? We know that for the most case, vector-borne disease, the burden is borne more by the global south than the global north. With climate change, we're seeing an increased geographic spread of those diseases, as I've alluded to. But even within a given geography, the distribution of these diseases is not equitable. So here's a case, or here's a study from Brazil and Zika virus, where you can see the density of microcephaly in children born to Black individuals versus white individuals in the same spaces. So these diseases are not equally borne by all populations. The authors of this study suggested that there were several reasons for this. There's poor sanitation in the areas in the favelas, increased standing water, increased mosquito breeding sites.
As a safety precaution.
Sorry? Unequal transmission. So in places with overcrowding, higher transmission, unequal susceptibility because of comorbidities and differences in nutrition, and unequal treatment, where inadequacy of the public health facilities and poor supports for children with congenital Zika virus syndrome in some neighborhoods. Here's a study from Philadelphia. We know that heat's not equally distributed, and so there may be parts of any given geography where there's more mosquitoes than others, putting certain populations at higher risk. Standing water is also not equally distributed. This is a study from Baltimore where they found more mosquitoes in all their forms in lower socioeconomic neighborhoods than higher socioeconomic neighborhoods. So this has been called the kind of mosquito gap, or the hidden inequality of mosquito bites. Mosquitoes being one of the main vectors for vector-borne illness, the contribution of this to the inequities of the diseases that we're seeing. So what tools do we have at our disposal to control vectors? We've been for years deploying insecticides to reduce the global burden of vector-borne illness. But we don't know exactly both the benefits and the risk. And when the Zika virus outbreaks were happening, we tried to put together some information on DEET, on permethrin. And again, there's not excellent data to really be able to counsel people and our patients specifically about this. So during Zika, we shared knowledge to our patients here about how to avoid insect bites, how to use appropriately registered insect repellents, how to treat your clothes. But again, when we're thinking largely in the global scale about vector control, you have these diseases that have profound morbidity and mortality. So it makes sense to try to eradicate the vector through things like insecticides. The problem is that there often then becomes insecticide resistance, and there's the potential for negative effects from the vector control as well. And so part of my own research has been in trying to extend models to be able to answer some of that question of the risk benefits. So I've been working probably for the last 10 or 15 years in Western Ghana, originally in a project on household air pollution, a project called GRAFS, where we randomized pregnant individuals in different communities to different cooking fuels and stoves. But during the course of that study, we collected urine at different time points and had the opportunity to go back and measure pesticide exposure among our pregnant cohort. And we're interested specifically in pyrethroids because that is one of the most common insecticides used for vector control in Africa as part of both insecticide-treated bed nets as well as indoor residual spraying campaigns, which basically go intermittently before the malaria season and spray the inside of homes with insecticides to decrease the risk of malaria. So permethrin is a pyrethroid. It is derived from something that's natural, from chrysanthemum plants, but it's known to be a neurotoxicant. We know that if given in excess, or if exposure is in excess, it can lead to acute neurotoxicity. And there's even been epidemiologic evidence that in low exposures from cohorts here in the US, there's the potential for developmental neurotoxicity. But how do you balance that against the real risks of something like malaria in an endemic area? So not to belabor the research that we've done, but part of the trouble with trying to answer this question on risks and benefit is the fact that these chemicals have very short half-lives. So when you go to do the epidemiology of the exposure response, you have exposures that are changing very frequently over the course of pregnancy based on what time of the year it is, what the diet's going on. And so how do you then sum the exposure and look at what's happening with the birth outcomes? And so I've had the real pleasure of working with a number of environmental health statisticians, as well as my Ghanaian colleagues, to begin to develop some models to help answer or be able to pose the questions and answer them in a way that's not as crude as methods in the past. And so there's something called multiple informant models, which have been extended to account for these time varying exposures for a given individual. So in graphs, this study that we were using, we collected almost 4,000 urine samples, somewhere between 1 to 5 samples per person, knowing that the pyrethroid pesticide exposure was not the same each day or each week for each person. And we're able to get a number of samples distributed over gestational weeks for the cohort. And through these, the multiple informant models, we're really able to extend, to be able to answer the question of how is the pesticide exposure at a given time point impacting a birth outcome like birth weight, and how might you sum it over the pregnancy. So in our study, there was 90% of people were exposed to 3-PBA, which the parent chemicals for this metabolite are in that pyrethroid family used in insecticide treated bed nets and IRS. And this is kind of sort of the output that you get from a study like this. So you can see the impact, the decrement in birth weight from exposure to the pesticide across the pregnancy. And then you can see that this accounts for nonlinear effects. You can give a summary over the course of the pregnancy as well. And so we were able to demonstrate a very small decrement in birth weight from a doubling of 3-PBA of the pyrethroid. And while this is not earth-shattering, I don't think that birth weight is where the toxicity of these chemicals are. But by sort of extending these models, we're able to look at these short, non-persistent chemicals across pregnancy and begin to pose questions about what are the risks, and then compare it to the benefits. So what we concluded that from our work was that prenatal urinary biomarkers of pyrethroid pesticides were negatively associated with birth weight, albeit small, and most of those effects were discernible in the second trimester. This is even in a place where malaria is very common, and so and malaria contributes to reduced birth weight. So I think it underscores, at least for me, that we need to be finding quickly, especially as our climate is warming, other ways to control vector-borne diseases, such as vaccines. And so I think that this is critical as we begin to think about sort of the complexity of what's at stake during pregnancy from vector-borne disease. So I wanted to make sure we left some time for questions. So I'll stop here and just summarize by saying that we know climate change is impacting global vector-borne diseases. It's increasing the geographic spread, the intensity, the frequency of these diseases. And it includes those that have specific relevance in pregnancy. And so we, as obstetricians, gynecologists, even here in the US, are going to be increasingly faced with a need to understand these diseases, the impact on our patients, and how we might advocate for improvements. These impacts are going to vary regionally. It's going to not be uniform everywhere. It's going to intensify in some areas. There's maybe some areas where vector-borne diseases or a specific one decreases. It's also not going to be equally distributed among all populations. We're going to need to, as a field, be part of the discussions around how to best control vector-borne strategies and begin to weigh the risks and benefits of the approaches. So I'm going to stop there. I feel like I'm rambling to my computer screen, and so I'm going to put it back on to see everyone's faces and be able to answer questions.
Great. That was amazing. I felt like I learned so much. Rashida, Sharice, and Katie, and Noe, if you want to come off mute and ask questions. My first question, Blair, is about, I heard the other day that when Katie, the woman who won the Nobel for the mRNA, is potentially there's downstream research on mRNA malarial vaccine. Have you heard about that? What do you know about it?
I know about as much as you do, which is that there is one that was being considered. I think that vaccines against parasites in general have been so tricky to perfect, if that's the right word. But I think, and full disclosure, I'm part of a group that's looking at a sporozoite vaccine being developed. So the sporozoite is a form of the parasite that infects the liver. So the first part of the malaria infection. So if you can develop some immunity there, then you can prevent it getting into the red blood cells and causing some of the anemia and the sticking in the brain and causing all of the severe sequelae. So this sporozoite vaccine has been developed. It's been tested in volunteers and children and non-pregnant individuals. And we are hoping in the near future to begin studying the vaccine in pregnancy, because I think that young children and pregnant women are the ones to target. But it's not going to be 100% like we think of our vaccines. You get vaccinated against, let's say hepatitis, and then you're done. It's like one and done. Think of this almost more like vector control, where you're reducing the chance that you're going to get the disease. The odds ratios are impressive, but they're not, 100%. So I don't know enough about whether an mRNA vaccine makes sense for parasite because of how many different sort of places that parasite is in your body. There's a lot of interest in developing a pregnancy-specific vaccine for malaria that would create immunity at that interaction between the parasitized red blood cell and the chondroitin sulfate A on the syncytia trophoblast. The problem is that when you look at the knobs, if you will, of the parasitized red blood cell, it's not just one knob that attaches to that, but a number of different ones. So to go from finding out what it's attached to on the placenta to actually creating something that will create that immunity has been not so straightforward, but there's some smart people working on that.
Can you tell us a little bit, you have a patient in front of you and she asks you about using the insect repellent, the permethrin. How do you tell her, given you have so much research there and so much knowledge, how do you tell her, like, practically how to apply it, how to use it? Is it once a day? What are the precautions that you give patients who might be using these products?
So permethrin is best used when applied to fabric.
Hmm.
So it is less of an insect repellent and more of an insecticide. So it's designed to kill the mosquitoes, not just turn them away, if you will.
Okay.
So permethrin is really used. So if you were going to a malarious area, you could pre-treat your clothes with permethrin, or sleep under an insecticide, a permethrin treated bed net. That's kind of the appropriate use of permethrin. And so for those of us who are not living in malarious areas or not with the specter of Zika outbreaks right now, probably permethrin is not what you'd reach for on your shelf to prevent mosquito bites, and would look to something that's more safe, that we think, like a DEET.
Oh, okay. So, this is just a side question. Do you happen to see in the patient population in Guyana the amount of hypertension that we see in the United States?
We do see a fair amount of hypertension. I don't think it's as well characterized as here. And there is some seasonality to the hypertension and preeclampsia that may reflect malaria as well. So there's some thought that angiogenic markers, if you will, there's some parallel between what's happening in malaria to preeclampsia. So some of what we attribute to preeclampsia may be malaria and vice versa.
Yeah, because I mean, you can't injure the placenta like that and not have some preeclampsia sequelae.
Yeah, absolutely. So there's definitely some overlap, and severe malaria looks very much to an obstetrician like severe preeclampsia.
Oh wow. Oh wow. Ali, do you want to ask your question?
I do have a question, but Noe, do you have a question?
Yeah, but I don't have to trump your question.
Thank you again, Blair. That was a really, really great talk. My question is, I think that it was the malaria section that you had, that in the past, it's definitely been increasing, but I think the last number was 2016. My question is, like, specifically as things have been getting worse and worse every year, do you think that all of these in general are accelerating like every year? Like, I know we saw the figures of what things might look like in 2030 and 2050 with like Chagas disease. I think I'm thinking of those maps, but each year, like, have you seen or heard of your colleagues in some of those places that, more people are getting affected?
I think it's very local, if you will.
Okay.
And so I think what I was trying to impart was how complicated, just take heat, for example, the impact that it has on the vector, on the parasite, and on the human behavior, all three interacting. So unlike it's less of an accelerating trend, if you will, than things in some places intensify, some places where you didn't see it before you get it, some places where it was there before it may actually decrease, in the case of malaria. So it's way more complicated than just all things are getting worse, right?
Okay. Yeah.
The vector, the mosquito that transmits both Zika and dengue, is one of the mosquitoes that's most well adapted to heat. And so I think that if we wanted to sort of focus our attention on one vector-borne illness that really is sort of dramatically increasing with climate change, it's dengue. And I think that it's not even really well ingrained in my mind as to what it can do to our patients. But we're seeing that, in some of my colleagues in Africa and in Asia, working in Pakistan, India, and Bangladesh, they're just seeing tremendous dengue outbreaks.
Wow.
And while it doesn't have the sort of devastation that we think of with malaria, when you expose just this many more people to the disease, even if a small fraction of them get the thrombocytopenia, get the dengue hemorrhagic shock, you're going to be, we're going to need to get a little bit more adept with understanding of what it potentially can do during pregnancy. So that seems to be the vector that really is thriving the most, if you will,
Okay.
with a warming climate. I will say that mosquitoes are, going to out survive us all. They seem to be very adaptable. They're adaptable to the insecticides that we sort of throw at them. The Anopheles mosquitoes in Africa, which tend to bite or have bitten at night for years, we threw bed nets up at them. They're starting to have Anopheles mosquitoes that start to bite during the day. So they're, adaptable, if you will. Not to bring us all down.
Yeah.
we need to be like the mosquito, I guess, is is the take home point there.
Well, to that point, and then we'll jump to Noe's question. In the chat, we have a neonatologist with us, Dr. Vereen, and she had said that also there's like already some notice of Chagas disease in that community over there. So I did not, before this talk, I totally thought, only Central America, not in the US. So this is really bringing it home.
And maybe I'll ask Dr. Vereen, do you know if that's locally acquired Chagas or Chagas from immigrants who have, come to Texas and weren't aware of their chronic Chagas before?
So unfortunately, I don't have all the information. I just know like the ID community here is very, very active and has a huge interest in sort of climate and the changes that they're seeing in their patient population. And when I say ID, I mean pediatric.
Yeah.
And I know of a colleague she's seen more than one, but I actually am so unfamiliar with how like the Chagas disease in general. I didn't even think to ask that question for my own education. I was just like, oh my God, I just remember learning about it in med school and haven't really thought about it since. So I will ask because I now know more about it because of this talk today. So,
yeah, no, and I won't pretend to be a Chagas expert at all. I mean, I think I remember the pictures from medical school of the bug and the hut, right? And then when I got interested in malaria, I was like, oh, maybe I can fashion myself as an obstetric parasitologist or something like that. And so like started reading about Chagas, but have never done any work on it, and have practiced most of my time in the Northeast where it is, it is less relevant right now. But talking to colleagues in Texas and Houston in particular, they have struggled with whether or not to universally screen for Chagas. So as you all know, screening for diseases depends on how good the screening test is. And as you know, with some serologic tests, there's a high rate of false positivity. And my understanding of the Chagas serologic test is that there is a lot of false positive results. So embarking on sort of universal screening amongst, even if you target it to those who, come from endemic areas, has some trouble. And treatment during pregnancy is not currently indicated with antiparasitic. But if you identify someone who might have chronic Chagas, you can then at least follow them and treat the newborn, which is, in the child, which can be treated. So it is a complicated question for, what should we be doing from a public health perspective? And I would just be interested whether, these bugs do exist in our country borders. Are they harboring the parasite yet? I don't know. And I don't want to pretend to know. But report back, Rashida.
Noe, you have a question?
Well, Blair, thank you so much for that excellent talk. I am in Pittsburgh. I'm an OBGYN here and worked with Allie when she was a fellow.
Oh, nice.
and really enjoyed learning. I specialize in healthcare sustainability, not climate medicine, but people expect me to know what you know. So I'm trying to educate myself. I was really interested that you didn't mention Lyme disease. So I know we just have a few minutes left, but if you could just give us the spiel a little bit. In Western Pennsylvania, that's obviously a huge deal here, and getting worse. And then I may have missed it, but I'm not sure if you talked about the safety of DEET relative pyrethrins. You did, obviously, but DEET, I missed that if you did. And then lastly, are there any natural insecticide? I use all these hippie, bug repellents. I'm wondering if you know anything about those and if there are any that actually reduce bites.
So let me first jump to Lyme, then DEET, and natural bug repellents. So for Lyme, my understanding is that, and again, I haven't spent a lot of time thinking about Lyme and climate, but with extended summers, extended periods of in the Northeast where we see a lot of Lyme disease, the ticks can survive longer. So the season for Lyme can increase. So it would make sense that Lyme could increase with a warming climate. That's about as probably deep as I can get without making something up. But my sense would be that ticks can live longer when it doesn't get cold, or if the colder season is short. With respect to DEET, we did some digging through the Pediatric Environmental Health Specialty, the PACU, when Zika was coming out, to try to figure out what was known about DEET and its safety. And a lot of chemicals are just on the market. They aren't sort of held to the same standards that a pharmaceutical would be, even when in fact their molecular structures are really quite similar. And so while certain legislation, our government has the right to sort of understand more, often that is not sort of enabled. And so many things come to market with very cursory sort of safety tests, and including what I would say is, many of these insect repellents. What we could tell from what was known in DEET and what the EPA was saying is that they seem to be fairly safe. But again, I would say that our knowledge is still limited. Unlike some of these insecticides, which are truly designed to kill via neurotoxic pathways, the insect repellent has a different mechanism of action. And so just from a theoretical basis, probably is less toxic, so to speak. I don't know, I can't begin to speak to the natural remedies without knowing sort of more about what they might be.
Sure. I was just wondering if you had a go-to you recommend for your pregnant women. That's fine. Yeah.
I don't really. I mean, we put together
no is an acceptable answer.
We put together a few sort of fact sheets on insect repellents at the time. And I'm happy to dig those up and share those with you. Again, it's sort of, what's known. And you're always balancing unknowns versus the risks of a disease. So for example, I traveled pregnant to malarious areas as a researcher, and I would spray my clothes with permethrin. I would sleep under insecticide treated bed nets. I would take anti-malarials because there's no way I wanted to get malaria when I was pregnant. And I just think that we sometimes get paralyzed by unknowns in obstetrics and don't weigh them against the sort of benefits of the unknowns, if you will.
Gotcha. Well, we are at time, and I'm worried about how big this file is going to be on my computer. So I'm going to wrap this up. We will be posting this on the OBG number 4 sf.org website, OBGYNs for Sustainable Future. And thank you to all who attended, and thank you so much, Dr. Wylie.
It was great. Thank you for having me, and really a pleasure to be with you all.
Thank you.
Thank you so much.